This is a quick video about acceleration and looking at a slightly different way to calculate it to what we have learned previously. Now, what we learned in a previous video is that acceleration is v minus u over t. V is final velocity, u is initial velocity, and t is the time taken. Remember, acceleration is in meters per second squared. The formula that I want to look at today is this one here. Acceleration is force divided by mass. It's important in this formula to remember that the force that we're talking about is the resultant force, and that's of course measured in newtons, and mass down here is measured in kilograms. So we can have a look at a quick example. Here we have a box that's been moved with a force of 20 newtons and the mass is 10 kg. So if we were to use this formula up here, it's very simply a case of 20 over 10, so 20 is the resultant force, 10 is the mass, and that becomes 2 meters per second squared. So that's a simple way of working out acceleration with the given data. There is another formula here, and you have to decide which one you might want to use in a given situation. So let's have a look at two examples. Have a go at these yourselves, decide which formula to use, give it a go and see what answers you come up with, and check them against mine. So for this first one, we've got a forward force produced by a car of 2,500 newtons. Calculate the acceleration, the mass is 500 kg. So you might have worked out that we're using this formula here. Acceleration is force divided by mass. We have a force of 2,500 newtons divided by a mass of 500 kg. So the answer in this case is 5 meters per second squared. That's acceleration. Don't forget to add the unit. For this one here, we've got acceleration from 10 to 25 meters per second in 3 seconds, so we use the other formula. We've got final velocity minus initial velocity divided by time taken, and if we plug the numbers in, we get a final velocity, the last velocity, of 25 meters per second. Take away 10 meters per second divided by the time it took, 3 seconds, and that gives us 15 over 3, which is 5 meters per second, coincidentally the same as the car. Don't forget to add the units. Okay, so there's a couple of examples there. We'll go through one last one very quickly and see if you can work out this one. Pause here, give it a go, and see if you can get the right answer. Just a little word of warning, you do have to be careful. There is a little stumbling block if you're not looking out carefully. Right, so the answers for this one is we use the formula acceleration is force divided by mass. The force in this case is not 23. Hopefully you managed to realise that it's the forward force is 23, but we've got a backward force here, which is probably air resistance and friction. We've got that force pulling backwards or pushing in the opposite direction. So the resultant force, remember I said it was important that you realise that's the resultant force. The resultant force in this case is 23 minus the 800, so that gives us 1500 newtons of force in the forward direction, and a mass, very simply, of 400 kg, which gives us an answer of 3.75 meters per second squared. Don't forget to add the units, very important. Okay, so a couple of ways of working out acceleration. Most important thing, remember we've got resultant force up here. The two formulas will be given to you in the exam. You will be told what the letters mean. You won't be given the units, so make sure you learn those.